All right, in this fourth lesson of Unit 5, we're again talking about quadratic formula. If you'll look at these steps right here, it's always nice to have steps. So that's a way to show you how to put your equations in order to solve them using the quadratic formula. Again, if they are factorable, you can also solve them by factoring, but in this exercise, be sure you follow the instructions. If the instructions say use quadratic formula, you do it. If it says factor, you do that. If it doesn't say either one, you use whichever method you prefer. So here is standard form: ax squared plus bx plus c equals 0. If there's anything on the other side of the equal sign, you're going to have to move it over so it looks like this. This number in front of the x squared is where you get the a. The number in front of the x is the b, and the constant is the c. So this says solve using a quadratic formula, round each to the nearest tenth. So let's do that. And first thing we're going to want to do is we want to figure out what a, b, and c are. So in this particular problem, a is 3, b is -2, and c is, now we want to say c is 6, but look, see where 6 is? So I didn't do the first thing like I said. We need to do 3n squared minus 2n minus 6 equals 0. First step is put it in standard form, so that makes my c a -6. So you have to be careful. I almost made the mistake I just told you not to do. And be sure you put everything in standard form before you pick out your a, b, and c. Now, number 3, carefully put it into the quadratic formula. So x equals, we're filling in the blank, negative, and b is -2, plus or minus the square root of -2 squared minus 4 times 3 times -6, all of that over 2 times 3. All right, so when we simplify that, we have 2, positive 2, plus or minus, and under the square root symbol, we end up with the square root of 76, all of that over 6. So now we have two different problems. We're going to have one is plus, so this first x will be 2 plus the square root of 76 over 6, and that's going to be, rounding to the nearest tenth, about 1.8. So that's one of my answers. The other one is 2 minus the square root of 76 over 6, and that's going to end up being x equals -1.1. So those are the two answers for number 1 here. Number 2, remember, one of the rules is we want the x squared to stay positive. So when we bring this other over, we have x squared minus x plus 8, subtracting x and adding 8 to from both sides, equals 0. So a is 1, b is -1, and c is 8. Putting it in the quadratic formula then, we have -1 plus or minus the square root of 1 squared minus 4 times 1 times 8. All of that over 2 times 1, or 2. So simplifying, we end up with +1 plus or minus the square root of 1 minus 32, so that's -31 over 2. Now remember, we can't take the square root of -31. If you try, you're going to get an error message. And so our answer is no real solution. Remember, that happens anytime you end up with the square root, trying to take the square root of a negative number. All right. Let's go on to the next page of notes. got one more example, and then we've got an application problem. Okay. Let's see if we can move this up just a little bit so we have more room to work. Okay. Now, here our x squared is negative right there, so we're going to move both of these things over, and that'll give us positive 2x squared minus 16x plus 32 equals 0. Now, to make this easier for our a, b, and c, and to work with smaller numbers, we can factor out a 2. We have a greatest common factor of 2. We don't have to. You certainly don't have to do the work, but you can. So we have x squared minus 8x plus 16 equals 0. Now, just looking at what's in the parentheses, our a then is 1, our b is negative 8, and our c is 16. I could have used 2, negative 16, and 32 and would have come out with the same answer. So x equals negative 8 plus or minus the square root of negative 8 squared minus 4 times 1 times 16. All of that over 2 times 1 or 2. So x equals 8 plus or minus the square root of 64 minus 64. All of that over 2. Well, 64 minus 64 is 0. The square root of 0 is 0. So that means this will have only one solution, because if you notice, when you're under the radical ends up being 0, you've got an equation that has a double root, because 8 plus 0 over 2 and 8 minus 0 over 2 are the same number. They're both x equals 4. And so our answer for each one is the same. So this one just has one answer. So it is possible to have one answer. My application problem here is a projectile motion problem. You throw in a ball in the air, and you start here at ground level, where we're going to say it's launched, rather, because it's launched from the ground. It goes up, it reaches its peak here, and comes down and hits the ground here. The path of the ball can be described by this equation, where height is equal to 35t minus 5t squared, and t is a time in seconds. So the first question, how high is the ball after 3 seconds? That's easy. That means that t equals 3. So we just put 3 in for these t's and want the height. H equals 35 times 3 minus 5 times 3 squared, or we have 105, I think, minus 45, and that's going to give you 60, and it's in meters. This height is the ball in meters, so our answer is 60 meters. After how many seconds will the ball be 50 meters high? So that means this is our h. H is 50. So we have 50 equals 35t minus 5t squared. Now, if you're using quadratic formula, it doesn't matter if this is negative. You doesn't have to be positive, but I still like you to get in the habit of bringing that and making it positive. So we're going to have 5t squared minus 35t plus 50 equals 0. Putting it in quadratic, I'm not going to bother to factor out a greatest common factor, because you really don't have to for the quadratic formula. We have negative 35 plus or minus the square root of 35 squared minus 4 times 5 times 50. All of that over 2 times 5 or 10. Okay. So we have 35 plus or minus the square root of 225 over 10. And our answer, when we work that out, I don't have enough room here, our answers come out to be 2 seconds and 5 seconds. Looks like an yes, that's a 5. All right, well, why do we have two answers? If one came out negative, we'd know we could let that go because we're not going to have negative time in this problem. But if you notice, what happens to the trajectory? If it's not at its peak, say this is your 50-meter spot right here. At 2 seconds, it hits 50 meters here. It continues on up, and coming back down, it hits it again at 5 seconds. That's why there's two answers for when will the ball be 50 meters tall, because it's going to hit it going up, and it's going to hit that level going back down. Last question, when will the ball hit the ground? The ball, what is the height here at the ground? Now, we're not looking for the beginning ground level. We're going to say that's at time 0. We're looking for where it hits the ground after it's through with its path. What is its height on the ground? Well, its height on the ground is 0. Even though there's not a value all the time in physics, I would have people say, I can't do that problem. It doesn't tell me how high it is. Well, it does. It tells you it's on the ground. And the height on the ground is 0. So we have the height is 0. And so that's going to be 35t minus 5t squared. Well, we don't have a term. We don't have a constant. We can factor this pretty easily. We can factor out a 5t, and that's going to leave me with 7 minus t in parentheses. All right, so 5t equals 0, so one of the t's is 0. That's the starting point where it starts on the ground at t equals 0 seconds. The ending point, 7 minus t equals 0, so 7 equals t. So how long did it take? When did the ball hit the ground? It was when time was 7 seconds. So after 7 seconds, the ball went up all the way. It started on the ground at 0t, went up and down and hit at 7t.